Third. Hello, everyone. Uh, Today I'm going to present our presentation about desktop application using Alarm. We are excited to walk through the genesis, development, and the capabilities of our desktop application designed with Tkinter. This application aims to make a sophisticated social network analysis more accessible and user-friendly. Let's begin the brief overview of our project. Uh, let's first talk about read the acknowledgement of our country. We respectfully acknowledge the Wurundjeri people of the Kulin Nation, who are traditional owners of their land on which Swinburne Australian campuses are located in Melbourne East and Outer East, and pay our respect to their elder past, present, and emerging. We are honored to recognize our connection to Wurundjeri country, history, culture, and spiritually through these locations, and strive to ensure that we operate in a manner that respects and honors the elders and ancestors of these lands. We also respectfully acknowledge Swinburne's Aboriginal and Torres Strait Islander staff, students, alumni, partners, and visitors. We also acknowledge and respect the traditional owners of the lands across Australia, their elders, ancestral cultures, and heritage, and recognize the continuing sovereignty sovereignties of all Aboriginal and Torres Strait Islander nations. Let's first talk about overview. So we are excited to share the fruits of our labor on the development of desktop application for SNA using alarm model. My team consisting of Fat, Jay, Mohammed, Tate, and Asad. Today, we will guide you through the evaluation of our application from a simple concept to a fully functional tool designed to streamline complex network analysis. Let's first talk about introduction and project background. Uh, in today's interconnected world, understanding the intricate web of relationship within social network is more crucial than ever. Our project addresses the urgent need for tools that simplify the analysis of these networks, making sophisticated technologies, methodologies like auto logistic actor attribute model, which is alarm, accessible to a broader audience. Now, challenges with the current tool. Many existing tools in the market require a steep learning curve or extensive programming knowledge, limiting their accessibility. Our solution aims to democratize this process, ensuring that valuable insights from SNA are within reach of unspecialistic without sacrificing the depth of analytical rigor. Let's move on to project scope and objective. And Ted gonna talk about this now.
Hi, this is Ted. So, I'll be explaining our core objectives. So, firstly, our mission was to design a software tool that is not only powerful in terms of computational ability, but exceptionally user-friendly design. So, the objectives include an easy uploading, robust validation of diverse data sets, a seamless integration of Alum for comprehensive network analysis, for real-time visualization of analysis results to enhance interpretability, efficient generation of detailed reports in a PDF format to facilitate academic and professional dissemination. So our project scope is that the application is to support a wide range of users from academic researchers to cooperate analysis, accommodating various data sizes from small academic data sets to a large scale industry data. So our project outcomes is that our design focuses on a single streamlined concept uh, that handles entire process of data input analysis and output. So let me walk you through the primary features of our design. Firstly is the data upload. Users can upload data sets in format like CSV or Excel files. And in an alum analysis, after data set is uploaded, the users can initiate alum analysis by simply pressing a button. The system processes the data to uncover relationships and insights based on the network attributes. And results of the visualizations, once the analysis is complete, the user has the option to visualize the data directly from the application. So we have implemented using matplotlib to render graphs, network diagrams in real time, giving the user an immediate view of the results. And lastly, PDF export. For users who prefer a hard copy or need to share the results, the system can export the analysis and visualizations into a well-formatted PDF report. The functionality is powered by Report Lab. Next, I'll be handing over to Asad for the design concept.
So the preliminary design concept. So our design utilizes a Python-based modular architecture with separate components for data handling, analysis, and visualization, ensuring scalability and ease of maintenance. The interface is very intuitive. It features a user-friendly GUI designed with Tkinter, making complex analysis accessible to users of all skill levels. The advanced functionalities integrate Python libraries like NetworkX for network analysis, Matplotlib for dynamic visualization, supporting robust alarm analysis and real-time graphical outputs. So the compatibility of the design. Our design successfully meets the requirements and expectations outlined for this project. We focused on delivering the following. Simplicity for non-technical users. The Tkinter interface was designed to be clean and intuitive, allowing users with minimal technical knowledge to easily upload the data, run the analysis, and visualize or export the results. There is also customization for advanced users, where they have the ability to tweak the dataset and view detailed analysis results in both graph and report formats. Code demonstration. Now I will hand over the mic to Jay.
Hello, my name is Jay, and I will be your person to be able to explain the code right now. Here, you can see that the application alarm estimation, which I have already ran. Well, now we can go back to the actual thing. We actually will be running it from the actual main code. So here is the actual welcome page. You can just click get started. And here is the actual alarm estimation app where you can upload your network file, your attribute file, your outcome file, binary file, and continuous file. So let's now start actually uploading those files. Um, Now we have uploaded the network file, the attribute file, the outcome file, which is one of the most important, the binary file, and the continuous files. After that, you can go on and select each parameters that you want to change the statistics of the actual lamb model on. So for right now, I will choose only the change activity and the change contagions. And over there, you have the GUF iteration step and the GUF burn-in step, where you can, so for the sake of time, we can just run 10 of it. But before that, we want to work on the run analysis. Since the run analysis is actually going to take a long time, we can go to this other three functions. Now, we can look for the visualize network, generate report, and actually generate graphs. The run analysis will only take a long time, so we won't be doing that right now. But in the main step, you will actually run the analysis first and then get the actual output for the actual output files to be generated before you actually do your visualization network, generate report, and actually generate graphs. Now, if you click on the visualize network, you will be able to generate a network using the network file. By clicking that, you can see that the code is running and the actual network file will be generated. But since it's taking time, we can go back to the application and look at all the other codes and functions. You can click on the actual estimation files, estimation application. And now the first one, which is generate graphs. Now the graph function will generate two graphs from the actual files that we have here, the GOF results and the output stats. Those are the two tables, which the GOF results is the GOF results that we get after running the GOF model on it, and the actual estimation results. Which we got from the first one. Now, this is the two um, graphs that we can see, the activity and contagion for the stochastic approximation results, and the other graph is the GOF T ratios result, which users can view and get an understanding of what's happening right now. And for the next part, we can generate the report. The generate report button is a function button which opens up another um, report generator, which the user can take the output file, the alarm output.txt, and drag and drop, which it will generate a alarm report.pdf in the actual folder. The viewers can actually see this, double click on it, and you will see an actual alarm model output report. So we have here the information, which is like, say, the graph information with total node 643, 819 with good graph density. And here we have the summary of the results where you can see that it generated a text format message that says the graph consists of 643 nodes, 18 edges, and then in the model estimation results, you can see the activity contagion, the estimation, and the standard error, and the model validation with the Mahalanobis distance, which calculates the actual distance function, and with the results that the GOF took. Since we only used 10 burn-ins and 10 steps, it took a very short time to actually generate. This PDF will be generated by the actual LAM folder, a LAM application. And now we can close this and reopen the application again so that we can reopen the application again so that we can actually run the analysis. Now we have to upload all the other files. Let's say the edge list, the attribute files, the outcome files, the binary files, and the continuous files. So here I'm just going to re-upload those files. And then click on the parameters that I really want, which is those change activity and take contagion, and set the actual burn-ins and iterations to very low. I'll be back after these files has been finished iterating on themselves. Since the estimation has been done, you can go ahead and just click on OK, and then a report generation, which is in a .txt file. The output is offloaded and printed out into a txt file that we can actually see. You can see here is all the actual raw output that the run analysis generated for all the steps it took, the actual model conversions, and the goodness of it model. Hope this actual application finds you well. So to recap and for future prospects, we have laid a robust foundation, but the journey doesn't stop here. Future enhancements will focus on integrating machine learning to predict network changes and expanding the tool's capabilities to a cloud-based platform for collaborative analysis. We invite the academic and professional community to join us in further developing this tool, exploring new features, and adapting into various other contexts. Thank you very much for your time. This has been Group 5 for the actual LAM project.